Thanks for your interest in this presentation. Here we are going to talk about the different chemicals that we can use to passivate stainless steel in the pharmaceutical industry, the process conditions, and the advantages and disadvantages of these approaches. Viscosity-wise, we have two options to passivate. The first one is non-viscous solutions that looks like water, and gels and pastes, which are very viscous and sticky. Acid solutions can be sprayed into the metal, can be recirculated inside the pipes and equipment, or items can be immersed in this acid solution. Gels and pastes have to be applied on the metal surface, and for this reason that surface must be accessible. Before any passivation, we need to clean always the metal with a base. The objective of this stage is to remove organic matter, which will be an interference between the acid and the metal. Rinse will eliminate any residues of chemicals. We usually rinse with high purity water. Hydrogen peroxide is a very common substance used in cleaning stainless steel in the pharmaceutical industry. These chemicals have two functions: sanitize if we are concerned about the microbiological quality of the system, and the second is create a better chromium oxide film that protects the metal from corrosion. If the metal has iron oxide or welds that were not done in an inert atmosphere, we will use pickling. When we recirculate solution inside pipes, it's a good idea before add any chemical to make sure the system is leak-free. Sometimes a pressure test or a leak test is part of the pre-commissioning package. We use dry when moisture affects the quality of the products inside the pipes, like in the case of pipes with gases or solids. When pipes were modified to be passivated, a pressure test at the end of the process will confirm that those pipes were properly restored. We can passivate using 50% nitric acid solution at room temperature for an hour, or 5% citric acid solution plus a little bit of surfactant, 280, for 3 hours at 180 degrees F. Better results can be gotten using chelanes. A typical chelan formulation will include molecules such as citric acid, ADTA, ascorbic acid, and 280. This must be held for 3 hours at 180 degrees F. There are many passivation pastes and gels ready to use in the market. Some of them have toxic compounds, and most of them will not provide documentation to prove the quality of the ingredients. An option is to prepare a viscous solution with a pH higher than 1 using polyacrylamidomethylpropane sulfonic acid. The polyacrylamidomethylpropane sulfonic acid is a cosmetic gel, stable from pH 1 to 13, stable in the presence of electrolytes, and soluble in water in any portion. A passivation gel can be prepared using this thickener, citric acid and chelate compounds. This formulation will have only cosmetic grade ingredients. If you decide to go with any of these formulations, you must know that temperatures, times, even concentrations are only guidelines, are not mandatory, and in order to document that you achieved the passivation, you must include a quality control test. If you decide to play around with the process conditions, you need to know the following. Citric acid works better at pH 4, so our concentration of citric acid is not recommended to go higher than 10%. Nitric acid is more dangerous at higher concentrations, but generally speaking, if you increase the concentration of your acid, the required passivation time will be smaller. If you increase the temperature, you will achieve passivation faster, but higher temperatures require measures to reduce the burn risk, and pumps can cavitate. And of course, there is also to be considered the cost of heating. Now, once that the passivation is achieved, an increase in contact time will not improve the process. This means once the passivation is achieved, there is no much better passivation. Longer time may not meet our requirements when the time is a constraint. In passivation, there are no solutions. We only have options, and we should be aware about the pros and cons of each of our options. Using nitric acid has the following advantages. Low cost, it can be used cold, required less contact time than citric acid, and same nitric acid solution can be used many times. On the other hand, it has the following disadvantages. It's hazardous. Additionally, to dissolve iron, also dissolve heavy metals that are toxic. It must be disposed, will not keep the metals dissolved after neutralization. I strongly recommend to avoid nitric acid for passivation in the pharmaceutical industry because the toxic compounds that will dissolve. Citric acid is very common use to passivate stainless steel in the pharmaceutical industry, and it has the following advantages. It's available in food grade and USP grade. It's not hazardous. Dissolves only iron, not the heavy metals that enrich the alloy. Its performance can be enhanced using other chemicals to generate passive layers better than nitric acid. It will keep the iron dissolved after neutralization. It's biodegradable. Disadvantages. It's more expensive than nitric acid, and low concentration solutions will require it to be heated up to 180 degrees Fahrenheit. Chelate passivation is recommended for the pharmaceutical industry or demanding applications, for example, the sausage ovens, which are in contact with hot sealant solutions. Chelate passivation has the following advantages. Only use chemicals that are food grade or USP grade. Is not hazardous. Dissolves only iron. Generate better passive layers than nitric or citric acids. It will keep the iron dissolved after neutralization, and the chemicals are biodegradable. On the other hand, it has the following disadvantages. Cost. Low concentrations solutions will require to be heated up to 180 degrees Fahrenheit, and it's a proprietary technology. Thanks for watching this presentation.